Hello, Assalamualaikum. I am Abia Hussain Anusha and my ID is 18101430. I am going to explain the proteus part of our project. Our project name is Greenhouse Management System. For our project Greenhouse Management System, we have used Arduino Uno, and here we can see a LDR1 sensor which is used as a light sensor, and here we can manage the distance of the light source, and this LDR1 is connected to a resistance of 10 kilo ohm and it is connected to a ground. And here we can see our temperature and humidity sensor, which is SHD21. Previously, we have used SHD11 sensor, which is not allowed, so we replace them with the SHD21 sensor. And LDR1 and SHD21 gives us analog input, so we have connected these two to the analog pin of the Arduino Uno. And here we can see exhaust fan and a shutter, which is connected to a driver because Arduino Uno supplies only 5 volts, which is not enough for the shutter and the exhaust fan because exhaust fan and shutter is 12 volts. And here we can see power source and ground connected to the driver, and driver is also connected to the Arduino Uno. And here we can see a virtual terminal which is also connected to the Arduino Uno, COM physical interface module which is connected to the Arduino Uno, and a sprinkler which is connected to a ground and also connected to the pin 2 of the Arduino Uno. If the light bulb is on, then the sprinkler is on. If the light bulb is off, then the sprinkler is off. And here we uploaded the hex file and for our project. So this is the final setup of Proteus part. So thank you.
Assalamualaikum, I'm Fatah Ahmed and I'm here to explain the code part of our project. My ID is 18101442. So here in the code we have included the library that we need for our code. SH221 is the sensor we are using for temperature and humidity sensor. We have initialized some variables and for the pins that we are using. And in the setup function of our code, we are declaring the pin mode, which are inputs and which are outputs. And the main thing is going on in this section, the loop part of the section. Here we are printing our conditions. So at first we are taking a delay of 500 milliseconds for taking inputs. After that, we are taking input from LDR as light, and we're taking input from SHT as humidity and temperature. And after that, we are meeting our conditions. So if you see here, if temperature is less than 18, the exhaust fan will turn off. And if the exhaust fan status is off, and if the temperature is less than 18 and light is greater than 512, that means the sunlight is present. Then and if the shutter is closed, then the shutter will open. And the shutter will open because we need sunlight, and since the light temperature is low. And if the light is less than 512, that means there is no sunlight. Then we'll need to close the shutter since there is no sunlight. After that, if temperature is greater than 35, we are turning on the exhaust fan so that the heat in the room can go out. And if the shutter is opened, we're closing the shutter off because if there's sunlight out there, we don't need sunlight. Now, if humidity is less than 55, that means the moisture is low, then we need to turn on the sprinkler. And if the humidity is greater than 55, then we need to turn on the sprinkler. So this is our code part. Now after that we export the compile binary as the hex file, and we input that hex file in this part here in Arduino. And if we see, we can see that it is completely running, and virtual terminal, yes, it is completely running. Thank you.
Hello and welcome to the LabView portion of this presentation, where I, Ifat Bashotcho, will try to explain it. At first, I rearranged all of the initial components, after which I started by creating the serial port part, consisting of the clear, open, fixed read blocks, flush, and the close, all of which can be found in the instrument panel. The clear block clears the buffer before starting, and the flush flushes it before ending. The reads takes the input, and for error detection, we have this. And to select the COM port, we have this. Now, I contained all of this within the while loop and connected the serial port part with it. Then I created a wait block which defines the input interval. After this, I connected the read to the byte count and took three fraction to um, numbers, which was in turn connected to the initial temperature, humidity, and light indicators. And it was also connected to the read buffers, thus completing my sensor reading process. Then I put the insert into array here, as we need a shift to happen after every iteration. We need a shift register. Now, a shift register requires a string constant and an array constant, which is here. Now, after connecting all of this, after one iteration, the array will move to a new line. Then I created a local table control variable, and in this we will give all the data that will be shown in the front panel. Now, I took a time block and another block which converts this time block's input into a string. And I took a build array block and expanded so that I could incorporate all my outputs required. And then I plugged in all of those outputs to it. And after that, I put a constant f here, and that's all for me. The next portion will be explained by my other group member.
Hello, I'm Adil Rahman. My ID is 191016667, and I will be talking about the open front-end part of our LabView project. Then let's start. So first of all, according to the COM driver right here, we have our proteus has a compim of COM4 and our LabView has a compim of COM5. Then let's start starting the project. We will see the virtual prototype, our virtual terminal right here. Then let's start the LabView, and we are already getting the readings where the shutter is open, the fan is off, and the sprinkler is off. If we turn the value of the humidity less than 55, we can immediately see that the sprinkler will turn on.